Kirchhoff's current law is based on the law of, okay, so KCL is based on, this is one of the standard bits, okay. So KCL, what is the KCL? KCL is nothing but, so algebraic sum of the currents at a node or junction is equals to 0. That means, otherwise we can give a statement like this, incoming current is equals to outgoing current. We can give like that, okay. So at a node or junction, so incoming current, how much current is coming is equals to how the same current has to go out from that node, okay. So similarly, so the Kirchhoff's current laws is based on what they are giving, okay. How much charge is coming, that much charge has to leave. At the same time, okay, you see one thing, okay, so for 1 hour if you calculate KCL, it will work. For 2 hours, it will work. For 10 hours, it will work. That means at any instant, Kirchhoff's current law will work. That means not only current, okay, so charge also balanced there. Okay, how much charge is incoming towards that node, same charge must leave from that node, okay. So that's why Kirchhoff's current law is based on, okay, so Kirchhoff's current law is based on law of conservation of charge. Okay, so this is the answer for this one, okay. Similarly, some questions will be there based on KVL, okay. So what is Kirchhoff's voltage law means? It is law of conservation of energy. Based on the voltage it is, okay. So based on the voltage and the time is also equivalent there, okay. So in the KVL, okay. So anyway, in different question we will understand about KVL. Remember, but okay, so KVL means it is the based on law of conservation of energy it is, okay. So now for this question answer is B, okay. Next question. In the circuit shown, okay, which of the following statement is not correct? Okay, so they have given which is not correct, they are asking. That means from the options you have to understand, okay. The first option, the circuit has a super mesh, okay. What is a super mesh? See one thing, this is a mesh, this is also a mesh. Okay, so what is a mesh means? Mesh is a closed path which further don't have any closed paths. Okay, so further we don't have any closed paths. Okay, so this is a closed path. Okay, so this is a closed path, but inside this is also a closed path. This is also a closed path. So outer one is not a mesh. This is only a loop. Okay, so what is a mesh means? Mesh is a closed path. Okay, so mesh is a closed path. Further it does not have any closed paths. Okay, that's why. This is one mesh, this is one mesh, okay. For example, if you want to write the mesh equations, okay, mesh equations, first we will write down as minus 20 plus 6 into I1 plus 2 into I1 minus I2. After that you have to write down the voltage in this one, because KVL equation is nothing but, okay, so KVL equation means, so Kirchhoff's voltage law, okay, so otherwise mesh equation we can write down, okay. So mesh equation we can call. Mesh equation is nothing but KVL equation only, okay. So we have to write down the complete mesh equation. But in a current source, it is difficult to write down the voltage directly. Okay, so directly we cannot write down the voltage because it is a current source. So this mesh equation you cannot write down. Okay, similarly, this mesh equation also we cannot write down because this current source is present. Understood, right? So these two separate mesh equations we cannot find out. That's why what you have to do, a combined mesh equation we have to write down like this. Okay, so that is nothing but a super mesh equation. Understood, right? When it is possible, whenever a current source is present between two mesh, okay, between two mesh, whenever a current source is present directly, okay, so then we cannot write down these individual mesh equations directly. A combined mesh equation we have to write down, that is nothing but super mesh. Okay, so this is nothing but the circuit has a super mesh. This is correct option only. What they are asking, which of the statement is not correct? Okay, this is correct statement only. Okay, and one more thing, they have given the current directions like this, right? Okay, so I1 current is in this direction, okay, I2 current in this direction. Okay, see this 6 amperes current is supported by this I2. Okay, so I2 is nothing but, okay, so I2 is supporting this one and I1 is against this one. So we can write down as I2 minus I1 is nothing but 6 amperes. Okay, 6 amperes is against this I1, okay, and I2 is supporting this one. So I1 minus I2 is nothing but 6. Okay, so this is another one. Otherwise you can write down as I2 is equals to 6 plus I1. Okay, so I2 is equals to 6 plus I1. This is also correct statement only. Okay, so now we will try to write down the complete mesh equation, that is super mesh equation. Okay, so the super mesh, however, we have considered like this. Okay, so remember one thing, when you are writing first mesh equation, first mesh current is superior. That means I1 is greater than any other current. Whenever you are writing second mesh equation, I2 is greater than any other current. Okay, so let's write down. First we are seeing, okay, so we are writing the KVL equation for this super mesh. First we have seen minus, okay, so minus 20. Next, wherever current enters, see current direction is like this, right? Okay, wherever current enters, that is plus, wherever current leaves, that is minus. Wherever this I2 current is going like this, right? Okay, wherever current enters, that is plus, wherever current leaves, that is minus. Similarly, plus and minus. Okay, so let's write down minus 20 plus 6 into I1. Okay, here current is I1 only. In this mesh means it is current I1 only. Okay, so plus 10 I2 plus 4 I2 is equals to 0. Why equal to 0? Algebraic sum of the voltages in a closed loop is equals to 0. That's what we are writing using a mesh analysis. Okay, so is equals to 0. We can write down as 6I1 plus 14I2 is equals to 20. Okay, 6I1, okay, 6I1 plus 14I2 is equals to 20. Okay, if 20 goes to other side, this option is also correct only. Okay, so remaining option is minus 20 plus 6I plus 6I1 plus 2I1 minus I2 is equals to 0. This is wrong option. So option D is correct for this question. Okay, so we have to choose the not correct one. Okay, see, while explaining, okay, so it will take little bit more time for us. Okay, but whenever in the exam, immediately you have to so check all these things. Okay, it will take only 1 minute to solve. Okay, next question. A wire has a resistance of 12 ohms. It is bent in the form of an equilateral triangle. The effective resistance between any two corners of the triangle is. Okay, so this is some different question. Okay, so previously they have asked 1 or 2 times only, so they may ask this model of questions. Okay, so what they have given, a wire is having how much of resistance? 12 ohms of resistance. This is the actual wire. So what they have did, it has bent in the form of an equilateral triangle. Okay, so if it has been bent like this as an equilateral triangle, so definitely, so entire length it will become L by 3, L by 3, L by 3, right? So whenever length becomes half means automatically, so resistance is proportional to L. Okay, so otherwise you can, you know the formula, R equal to rho L divided by A. Area of cross section is not changing. Okay, if this is the wire, whatever you are seeing, this is the area of cross section. So this is the length. Okay, so area of cross section will never change. Okay, so under material property, rho is also not changing. Same wire only we are bending. Okay, we are not changing the copper wire into aluminum. Okay, so same wire only we are using. That means here how much length is there, based on that resistance will decide. Okay, so definitely 12 by 3. Okay, so here 12 by 3 will be there, here 12 by 3 will be there, here 12 by 3, and the complete one is nothing but 12 ohms from here to here. Okay, so 12 by 3 here, 12 by 3 here, and 12 by 3 here in terms of ohms only, everything. Okay, so now what they have given, so effective resistance between any two corners, they were asking between any two corners. So if we check the equivalent resistance, what is that value they are asking? Okay, so let's check what it is. So it is like, so two resistances are connected like this. This is 12 by 3 and this is also 12 by 3, and in between these two, so we have another resistance of 12 by 3. Between these two terminals you have to calculate the resistance. Okay, equivalent resistance. So these two are connected in series, so you can observe, right? Okay, 12 by 3 plus 12 by 3, so what you will get? 24 divided by 3. Okay, so 12 by 3, 12 by 3, you will get 24 divided by 3. You can simplify this value also, no need. Okay, so 24 divided by 3, you will get, so 3 ones, okay, so 3 8s. Okay, so 3 ones, 3 6. Okay, not 6, so 3 4s it is. Okay, so and this is nothing but 8. Okay, so 4 and 8 both are connected in parallel now. Okay, so because of these two you will get 8 ohms, because of these two you will get 4 ohms. Okay, so now between these two terminals you need. Okay, so anyway 4 in parallel with 8 means 4 into 8 divided by 4 plus 8, so 4 plus 8 means 12 you will get. Okay, so in the denominator it is 12. Directly we can write down, so 12, 4 ones, 4 3s. Okay, so 8 by 3 will be the answer for this question. Okay, so equivalent between these two corners. Okay, so if they mention A, B, C terminals also, then no problem. Okay, we can do. Okay, so answer for this question is 8 by 3. Okay, so same question only they can ask in a different way. Okay, so I will give you, just understand. Okay, so they have the total length of 12 ohms. Okay, total length we have the resistance of 12 ohms. If they divide like this, okay, so if they divide like, so total half first. Okay, so half first. Okay, half of the length they have divided first, then remaining half they have given half and half. That means this is L by 4, this is L by 4, okay. And again they may mention, okay, so the point is nothing but A, here point is B, here point is C, here is D, okay. They can ask resistance between any two, okay, and this point C and D are connected means this also becomes C. Then they will ask, what is the resistance between these two, what is the resistance between these two. They may ask in this model also, okay. So they may ask, but still now they have not given in this model, okay. We can try this model, okay. Next question, okay. An ideal current source has 0, okay. So they are asking the property of current source, okay. What is the properties of current source? So we should know before only, okay. So an ideal current source, internal conductance, okay. So 0 what? Internal conductance or internal resistance, voltage on no load, 0 voltage on no load, or ripple, okay. So what is the answer we have to know, okay. So current source means, what is the property of current source? Current source generally having internal resistance that must be in, okay, so that must be in parallel to this, okay. This is the practical current source, okay. Current source value I, and there will be some resistance, okay. Now what they have given, ideal current source. Ideal current source means, what is the internal resistance value? Infinity ohms, okay. Internal resistance is infinity. That means whatever current is coming like this, same current has to go like this. Understanding, right? If it is practical current source means this resistance value must be high value. So whenever resistance is high, very less current will go in this one, remaining all current will go to the load side, okay. That is the actual analysis, okay. So now whenever it is ideal means infinity ohms. Infinity ohms means it is the open circuit. Understanding, right? Open circuit. So resistance of, okay, so resistance of ideal current source is must be equal to infinity ohms. This is one point, okay. This is one point. So what is the current? Loss current, it is 0 current, it is, okay. So what is the current going inside the internal resistance is nothing but 0 current, okay. So now what they have given, resistance equal to infinity ohms, we know, okay. So internal resistance, 0 internal resistance, wrong option, okay. This is wrong. Understood, right? Resistance is, internal resistance is not 0, it is infinity. Voltage, okay, so 0 voltage on no load condition, okay. So 0 voltage on no load condition. So it's not like you will get 0 voltage between these two, okay. So there will be some voltage across the current source also, there will be some voltage definitely. You may not get under no load condition, okay. So that means voltage will be present, okay. Whenever you short circuit also, there will be huge current flow in this one, okay. So we cannot confirm this ripple, we cannot confirm this ripples also in the DC system, okay. So they have not mentioned this is DC or AC. Anyway, ripples we cannot expect anything, okay. So conductance, you know what is the conductance? Conductance G equal to 1 by resistance, okay. So 1 by infinity, resistance equal to G infinity means 1 by infinity is nothing but 0, okay. So 0 more, okay. So 0 internal conductance, okay. So this is the correct option, okay.